Hello everyone, welcome back to my channel. I am Vamshik Shetty, pursuing final year B in Sri Venkateswara College of Engineering, Bangalore. Today in this video, we are going to discuss about the one of the important research on the deep learning, that is a deep learning system for the prediction time to progression of the diabetic retinopathy. We are going to discuss about the diabetic retinopathy using the deep learning. Now let us delve into the deeper. First, we are going to discuss on the introduction, where the leading cause of the preventable blindness is adults with the age of 20 to 74 globally, though risk of the DR progression varies significantly among the individuals. Yearly screening for all the diabetic patients is inefficient, and the deep learning can offer personalized risk prediction and improving the screening effectiveness. So this is about the overall introduction on the research. Now let us discuss on the problem statement, where the lack of individualized risk models, where the no existing model accurately predicts the diabetic retinopathy progression for the individuals, where the uniform screening intervals, where the current guidelines recommend the uniform yearly screenings leading to the over screening. And the economic and the clinical burden also can be seen, where the increased cost and the unnecessary clinic visits for the low risk patients. And the main objective is to develop a deep learning model to predict the diabetic retinopathy progression over the 5 years, optimizing the screening and the frequency. This is about the overall problems that can be faced in the diabetic retinopathy. And the main objective is to develop a deep learning model to predict the diabetic retinopathy progression. So this is about the problems and the objective. Now let us discuss about the deep diabetic retinopathy plus system for the overview and their overview. The main purpose is to predict the time to diabetic retinopathy progression from retinal images using the deep learning, where the input has been taken from the fundus images and the clinical metadata, and the outcome is to give the personalized prediction of the diabetic retinopathy progression within 1 to 5 years. And the innovations is to combine the retinal images with the deep learning to provide individual risk assessment. As you can see, in the first images we have taken the input, and the in the second image where you can see the output, and the third is the outcome, and the fourth is the where innovations of the deep learning can be seen in the form of the graph. So this is about the deep diabetic retinopathy plus system and this and their overview. Now let us discuss on the data and the cohorts. The training data sets, where we have pre-trained on the research has been pre-trained on the 7,17,308 fundus images from 1,79,327 participants with the diabetes who are having the diabetes. And the validation is the multi-ethnic cohort of the 1,18,868 images from the 29,868 participants. The external validation has been also provided with the tested across the 8 independent real-world longitudinal cohorts. And the what are the diversity in the population, where it includes the data from the different ethnicities, ensuring the model generalizability. So this is about the what and all the how the training and the validation can be takes place. So this is about the training and the training of data and the cohorts. Now let us discuss on the performance of the deep diabetic retinopathy plus system, where the concordance index were achieved a C index between the 0.74 and the 0.846, indicating the high predictive accuracy. So this is one of the major performance of the DeepDR Plus, where they have integrated the Braille score, that is IBS. It ranges from the 0.153 to 0.41, demonstrating the strong model calibration. And the real world validation is they are comparable performance in the external datasets, confirming the robustness. And the low resolution capability has also been can be seen in the DeepDR Plus, where the system performed well even with the low resolution images such as 128 into 128 pixels. So these are the some of the major performance of the DeepDR Plus system. Now let us discuss on the subgroup analysis. So the subgroup 1, where the prediction from no DR to onset of DR. So this is the subgroup 1, and the subgroup 2 is the prediction from the non-referable DR to the referable DR. This is the subgroup 2, and the subgroup 3 is the prediction from the non-vision threatening DR to the vision threatening DR, that is VTDR. So this is about the subgroup 3. And high predictive accuracy can be seen where the C index between the 0.820 and the 0.895 for those specific progression types. This is about the subgroup. There are three subgroups, that is the subgroup 1, 2 and 3, and the high predictive accuracy can also be seen by the C index. So this is about the subgroup and the predictive accuracy. Now let us discuss on the real world impact, where the DeepDR Plus could extend the screening intervals from the 12 to 31.97 months, and the reduction of up to 62.46% in the screening frequency and the saving resources. Only 0.18% delayed detection of the progression to vision threatening DR, and the model allows for the stratifying patient into low and high risk categories, guiding care. So this is on the impact that has been taken place by the introduction of the introduction of the DeepDR Plus system on the real world cases. Now let us discuss on the clinical application. So the integration into the workflow. The system can be integrated into clinical practices, supporting the personalized care, and the efficiency also been can be seen where the reduce overscreening in the low risk patients while focusing resource on the high risk individuals. And we can also see the improved outcomes where the potential to improve the early detection and the prevention of the DR in high risk patients. And the economic benefits also can be seen where the optimized screening intervals can significantly reduce the healthcare costs. So these are the some of the four application, that is the integration into workflow, screening efficiency, improved outcomes, and the economic benefits. So these are these four major in clinical application. Now let us discuss on the explainability and the model interpretation, where the model focuses on the key retinal areas like vessels and the fovea for the predictions, and the identified changes in the retinal vessels are the strong predictors for the DR progression. And the fundus score contributes most to the predictions, followed by the clinical features like blood pressure and the HbA1c. And the visual explainability enhances the trust and the adoption in the clinical environments. As you can see in the figure, Baker model for the retinal areas like vessels and the fovea for the predictions, and the identified changes in the retinal vessels are given the examples for the diabetic retinopathy progression. So you can see the changes in the figure. So this is about the explainability and the model interpretation. Now let us discuss on the conclusion. What are all the we have concluded from this research, where the accurate predictions is one of the major concluded point in this research, where the deep DR plus accurately predicts the DR progression, that is the diabetic retinopathy progression, personalizing care for the diabetic patients. And the screening interval extension also can be seen, where the potential to the extend screening intervals, reducing the unnecessary visits. And clinical integration also can be seen, where the system can be integrated into real world clinical workflows to enhance the deep DR, that is diabetic retinopathy management. And the future potential can be seen where the model could be adapted for the other retinal diseases, expanding its utility and the ophthalmology. These are some of the concluded points we have been taken from the research. So this is about this research about the deep diving on the diabetic retinopathy cases. So these are some of the reference paper that we have taken from the we have taken as the reference for our system, that is deep learning for the diabetic retinopathic predicting cases. And you can check out this reference paper for your purpose. Yeah, this is about the reference section. Yeah, that's it for this video. Thank you. For more videos, please like, share and subscribe the channel. Thank you.